Alright, so 5.6 half-angle identities. You'll want some paper and your trig book for this lesson. Alright, so we're going to be looking at deriving the identities, applying your half-angle identities, and also simplifying expressions and verifying identities. Objective 1, deriving the identities. So take a second to look on page 241 at the derivations of the identities, and then answer the following 3 questions. It's kind of 3. So with question 1, which set of the identities do you start your derivations from? And then what you can do is match up column A here with column B. Okay, which of these identities match up? Okay, so which one goes with which? And then look at number 2 down here. How do you know which sign to use? So if is it positive or negative? So pause the screen, take a look at that. Okay, so for number 1, the answer is that you are actually going to be using your double angle identity to derive all 3 of them. Now you're not using your normal double angle identity for cosine. You'll be actually using the alternative angles for it. So it's a little bit of a tricky question. And then if you were to match up the rest of your identities, A actually goes with T and B goes with E, but your correct answer is C. And then if we look at the green box with the half-angle identities, I'm going to go to the next slide to explain that one. Okay, you will select the plus or minus sign according to the quadrant where A over 2 terminates in. So you can read this example to give you an idea of how to decide if the sign is positive or negative, but it's dependent on the quadrant that it's in. Okay, so your quadrant is important. Pause at any time if I'm going too fast. So task 3, check out examples 1 and 2 and answer the following questions. So you'll want to pause again. So in this problem, we can find what our A value is by starting off with the idea that we're looking for a tangent of A over 2. Alright, so in this case, we know that tangent of A over 2 is going to be equal to tangent of negative pi over 8. Okay, so you can solve for A by taking A over 2 is equal to negative pi over 8. Now, this problem is a little bit tricky because if you look at this, you'll see you would think, okay, my answer is going to be C or D because pi over 4 is equal to 45. However, B is also a correct answer if you start off by looking at the fact that tangent of negative theta, okay, so that's a negative theta there, is equal to negative tangent of theta. So you can also think of A as being pi over 4, not negative pi over 4. Now, when we go down to the next part of the problem, and I'm not going to walk you through step by step, you guys can look at that and ask questions in class, but when I started this, I used this identity right here to start. So notice how I pulled out the negative here, and then I went and you can actually use any of your 3 identities in this box here. Okay, so you can choose which tangent half-angle identity you use, and it doesn't matter, whichever one works best in the situation. So I just chose to use this one right here. Okay, I think this one and this one are equally easy. Alright, and then you plug in the values that you're given. So we know that our A value is going to be pi over 4. Okay, so you just plug in your theta value into the equation and simplify. So pause to take a look at the end of this example. Oh, stinky Sue. So don't look at the answers, cover it up, don't look at it. Give yourself a second to actually try the problem of finding tangent of theta over 2 if you're given sine of theta is equal to 3/5. Alright, using example number 3. Just try it. You guys are smart, you can figure it out. So pause the video. Alright, I'm assuming most of you have already looked over the answers, so if you haven't, take a second to do that. I'm going to point out a few things. Alright, so first off, you want to generally find your angle first. That's what this part is here. Okay, find where your angle is, in which quadrant that your half angle is in, so you can tell what the sign is. And notice that all of these are positive. Okay, and then when you're actually finding your tangent value here, you can use whichever one you want. Okay, whichever tangent of half angle identity you want. Now I chose Pikachu, just kidding. I chose this identity here. There's not an exact reason why, I just think that one looked easy. Okay, so the easiest. I didn't want to do the square root one because that's just going to complicate things. And the other one is just about the same. Okay, so you choose whichever one you want. Now the problem is we don't know what cosine of A is. Okay, we don't know what that is. However, you can find what cosine of A is, alright, using another identity. So that's what I did right here. Okay, so we need to find cosine of A. And I did that by using my Pythagorean identity. And this is actually theta, sorry. And you get that cosine, whoops. Okay, that cosine of, oh, it won't let me erase that. Okay, that mark stays. Cosine of theta is equal to -4/5. Now, we'll actually go ahead and use that mark. So I want to give you an idea of what this looks like. So we're still dealing with theta, all right, not theta over 2. So we know that theta is, and it says up here that theta is between 90 and 180. Okay, so it's over here. All right, and we know that sine is equal to 3/5. So sine is going to be opposite of our hypotenuse, fifths. Alright, and then this is a 3, 4, 5 triangle. So then we'll have our x value will be -4. Now that we can reaffirm the idea of what cosine is, because cosine of theta is equal to adjacent, so -4 over hypotenuse, which is 5. Alright, well, worry, my mom came and interrupted. So let's see. So we just found what cosine was. Alright, so then since we know what cosine is, and it's negative because we're dealing with just this angle, okay? Your half angle is positive. Okay, so because your half angle is in quadrant 1. Your actual angle is in quadrant 2. Don't get confused. Alright, so then we go and we can find what tangent of the half angle is by plugging in our values. So I have 1 minus cosine, we found cosine. And then you simplify to get that tangent of your half angle is equal to 3. Yay! Alright, so check out examples 4 and 5, okay, and then we'll go over the answers in a second. So pause the video. Alright, so your answer is here. So if we are going to try and write this as a single function, okay, single trig function, what you want to do is think, which identity does this look like? And obviously it looks like tangent of your double angle, or your half angle of tangent. So, and let's just recall that's equal to plus or minus square root of 1 minus cosine cosine of A over 1 plus cosine of A. So it's easy to see, and we're looking at B here. What would A be? Okay, A is obviously going to be equal to 8x. Okay, so if we're rewriting this as a single trig function, we're going to rewrite it as tangent of A, which is 8x over 2. Okay, so it would be equal to tangent of 4x. Yay! And last problem, I'm just going to let you look over these solutions on your own. Alright, but I wanted to point out there are two different versions. You can either start with your right hand side, or I showed you another way of doing it if you start with your left hand side. Another option is to start on your right hand, get to a point, start on the left hand, get to a point, show that those are equal. Alright, I hope this helped.